Now that we know the basics of vectors and vector operations, we'll do some example problems. So first we want to find the sum of the vectors -2, -1, and 3, 4, both algebraically and geometrically. So algebraically, we simply add up the components, so -2, -1, plus 3, 4. So we add the components, -2 plus 3 gives us 1, -1 plus 4 gives us 3. So the sum of these two vectors is the vector 1, 3. Now let's think about how to do this geometrically. So the first thing I'm going to do is just plot our two vectors. So -2, -1 means we are over -2, down -1. So here's our first vector, -2, -1. And now 3, 4, so I'm over 3, up 1, 2, 3, 4. So here's our vector 3, 4. So to add these two vectors, I'm going to take my -2, -1 vector, stick it on the tail of my 3, 4 vector. So I get this guy. So I just take it and I move it over and stick it on the tail. And now I draw the vector that connects the two. So the starting point of the 3, 4 to the ending point of this new vector that I've shifted over, and we do get this vector 1, 3 that we got when we did this algebraically. So you pick up the vector you're adding on, you move it over to the end of your first vector, and then draw in the vector that connects the two. Okay, now let's do an example in 3 dimensions. So here we have A is -3, 4, -1. To make sure we understand the notation, this means -3, 4, and -1 are the components. B is the vector 6, 2, -3. And you can either leave it in your IJK form or just write it out in component form, whatever way you prefer. So the first thing we need to find is the length or the magnitude of A. So remember, this is the square root. We get -3 squared plus 4 squared plus -1 squared. So this gives us the square root of 9 plus 16 plus 1. So we get the square root of 26. So the length of A is the square root of 26. For A plus B, we're going to add the components. So -3 and 6 gives us 3, 4 and 2 gives us 6, -1 plus -3 gives us -4. For A minus B, we subtract our components. So -3 minus 6 minus 9, 2, -1 minus -3 gives us -1 plus 3, which is 2. For 2A, we just multiply each component by 2, so -6, 8, -2. And again now, this is a vector in the same direction of A, but the length is twice the length of A. So we know that the length of 2A, we don't have to do out the square root computation, it's just 2 times the length of A, so it's going to be 2 root 26. And now the last thing we were asked to find was 3A plus 4B. So first let's write out what 3A was. So we just multiply all components by 3. So we get -9, 12, -3. And then we're going to add on to that 4B. So we'll multiply all components of B by 4. So we get 24, 8, -12. And now we just want to add these together. So -9 and 24 we get 15. 12 and 8 gives us 20, -3 and -12 gives us -15. So the point of this example is working with our 3-dimensional vectors algebraically, and again, you can either work in component form as I've done, or you can work in the IJK, the basis vectors notation. In our next example, we want to find a unit vector. So remember, this is a vector with length 1. So we want to find a unit vector that has the same direction as the vector 1, 2, -5. So let's call this vector 1, 2, -5, let's call it A. The first thing we need to do is find the length of A, or the magnitude of A. So this gives us the square root of 1 squared is 1, 2 squared is 4, -5 squared is 25. So we get the square root of 30, or if you want, so the square root of 30 is the length of our vector. Okay, so square root of 30 is the length of A, so then a unit vector in the length of A, I'm just going to take A and multiply by 1 over the length. So multiply by the scalar 1 over root 30. So 1, 2, minus 5. So I can write this in component form as 1 over root 30, 2 over root 30, minus 5 over root 30. Or if you like the IJK notation, so this is 1 over root 30 I plus 2 over root 30 j minus 5 over root 30 k. Alright, so we found our vector. Finally now let's just check that it works. So I need to find the length of this vector, so I'm going to do the square root of 1 over root 30 squared plus 2 over root 30 squared plus minus 5 over root 30 squared. So this gives us, when we square everything, so we get 1 over 30 plus 4 over 30 plus 25 over 30, which gives us, adding up, we have a common denominator, so adding up our fractions, we get the square root of 30 over 30, or the square root of 1, which is 1. So we have found a unit vector because it does have length 1, and we know it goes in the same direction as our original vector because it's just a scalar multiple of our original vector. Alright, so in our next problem, I want a vector of length 3 in the same direction as this vector A. So A, in the previous example, we found that the length of A was equal to root 30. So we found that U, I'll call this next vector U standing for unit vector, so 1 over root 30, 2 over root 30, minus 5 over root 30. We know this goes in the same direction as A, and it has length 1. So that's how we found this vector. We took A and divided by the length of it. Okay, so to get a vector of length 3, we're just going to do 3 times this vector. So we're going to get 3 over root 30, 6 over root 30, and minus 15 over root 30. This now is in the same direction as A because it's just a scalar multiple of A. We first multiplied it by the scalar 1 over root 30, then multiplied by the scalar 3, so we're just a scalar multiple of A, so we are in the same direction. So this vector is in the same direction as A, and now it has length 3. Because we first found a vector in the same direction as A with length 1, and then we multiplied that by 3 to get length 3. And you can check, I'll leave you to do that, you can check using your formula for the length of a vector that the length of this actually is 3.